Hi and welcome to logs. Okay, this is a really it's a quite a fun section. I think it's all about understanding what a logarithm is and understanding that logarithms are entirely and totally connected to exponents. Okay, logs on its own, it doesn't form an enormous section of your syllabus, so just know that. Where it will crop up is very likely in the first couple of sections of your paper 1 exam. All right. But primarily the use of logs most often gets used in financial maths, okay, where you are solving for an unknown exponent, all right, and yeah, we can't apply kind of normal ways of doing it, but obviously we'll get through all of that. So just to give you a background of where logs fits into the syllabus, that's pretty much it. But yeah, it comes along with a whole lot of laws that we need to understand and just obviously an understanding of what a logarithm is actually about. Okay, so let's talk about that. What is a log? All right, essentially this is it. A log is just another way of writing an exponent. Okay, so think about that. It's another way of writing an exponent. Okay, so let's look at this example over here. If I have a to the power of x, in fact I'm going to make x a different color because that's the exponent, so a to the x equals y, all right? That's exponential form, all right? Now I'm going to take it from being an exponential form and I'm going to convert it into logarithmic form. Now according to the definition, a log is another way of writing an exponent. So if that's the case, we need to make the exponent the subject of the equation when we change it into log form. So you can see that the exponent has now been made into the subject of that equation, okay? And we say x is then equal to log. Now the base of this equation over here was a base of a. So a log always has a base, all right, sitting as a subscript down there next to the log. The base of that log is always the base of the exponent, and the y over here represents the value of what a to the power of x. Okay, so it's the power value over there. Okay, so there we go. That's how we write it from exponential form to logarithmic form. Okay, and that's essentially, like I say, it's taking the exponent, taking this little guy over here, and making it the subject of the equation, which means that we introduce this as a logarithm. Okay, just a bit of terminology. Make sure we clearly understand that if you've got a power such as this, the base of a, this a over here represents the base. This is my exponent, and a to the power of x, that value of it is we're going to call the power value. Okay. All right, so let's quickly practice a little bit where we're writing something that was given to us in log form. We're going to write it in exponential. This is a very important thing you have to be able to do. It's just essential that you know how to do this. Okay, so remember we said if it's in log form, the value that it's equal to is actually the exponent. Okay, the value down here is actually the base. So if I were to write this back into exponential form, I would take the base of 2, the exponent is 4, and 2 to the power of 4 is that 16 over there. All right, got it? Let's try again. I'm changing into exponential form. The base is 3, the exponent is 2, the power is 9. So 3 to the 2 equals 9. Okay, what if I've got this? I've got log m equals n. What's missing? Okay, do you see that I don't have a base down there? All right, now there's something really important that we need to know about logs. Our normal number system, the one we work in day to day, is in a base 10. Okay, so it's assumed the base 10 is the number system. Similarly, if you don't see a base here, it is assumed we are working with base 10. Okay, so just be aware of that. If you don't see it, it is actually there. All right, it's just that obviously it's a base 10. All right, so what would this be in exponential form? The base of 10, the exponent is n, and 10 to the power of n is giving us that m value there. Okay, let's do one more. Log 5 equals 2, okay? this actually wouldn't technically be 100% correct. Let's just think about it. Okay. The base is 10, all right, so 10 to the 2. You know what, let's fix this to make it actually work. Otherwise, I'm going to land up with something that doesn't look quite right. Let's make that 100, okay? 10 to the 2 is equal to 100. Can you see why I was having a problem with the 5? 10 squared is definitely not equal to 5. Okay, so there we go. That's how we change it from log form to exponential. Let's quickly practice it the other way around, from exponential to log. Here we go. The exponent is 2, which is equal to log. The base of the exponent was 5, and the power is 25. Okay, happy with that? The exponent is m, which equals log base p x. Okay, I've got x equals log base y a. Okay, and the last one over here I have got 2 equals log base 10. Okay, so I'm actually not going to write it because it's assumed that it's base 10 if it's not written, to the 100. Okay, there we go. So that is an essential skill that you must need to know how to do in order to move further with logs. All right, so practice that, and I will see you in the next video where we start talking about the laws of logs. See you soon.